Hello students, chapter is Redox Reactions, lecture number 1. In this lecture, we are going to study what is a redox reaction. We will also talk about redox reaction. It is made up of which two processes, oxidation and reduction. And we will study different definitions of oxidation and reduction in the same lecture. What are the different definitions of oxidation and reduction that you will have to remember? One type of definitions we study commonly are classical definitions of oxidation and reduction, and second type of definitions that nowadays they have become more common, they are known as modern definitions for oxidation and reduction. Okay, student, this is the focus of our lecture. So let's start with what is redox reaction. First of all, you must remember what is a redox reaction. Redox reaction, it is a combination of two sub reactions. Redox, it is a combination of reduction, red for reduction, and ox for oxidation. So how you people can remember to define redox reaction? Simply you can say redox reaction, it is a chemical reaction in which both reduction and oxidation, they must take place simultaneously. Whenever reduction and oxidation take place simultaneously, this type of reaction is known as redox reaction. Now what does simultaneously mean? It means that wherever there is reduction, oxidation is compulsory. Without reduction, oxidation is not possible, and without oxidation, reduction is not possible. So this is the simple information to start with. You must remember what is a redox reaction. Second thing, there are two different styles of definition that we can remember to differentiate between reduction and oxidation. The classical method for defining reduction and oxidation we are going to study first of all. So according to the classical method, what you must remember, oxidation and reduction, they were defined based on two common elements. What are the two common elements based on which oxidation and reduction were defined? One element is oxygen and the other element is hydrogen. So simply from the name of each element, it is quite obvious, you can guess quite easily that oxidation will be based on oxygen and reduction is based on hydrogen. To start with, just remember this difference, that first definition that we will write down for oxidation, we will link it with oxygen and we will link reduction with hydrogen. Then later on we will modify this definition and I will explain it to you. Right now, as I told you, to begin with, what you must remember, oxidation is linked with oxygen. So how you can define what is oxidation? According to oxygen, in terms of oxygen, oxidation is the addition of oxygen. Oxidation is the gain of oxygen. Oxidation is the increase in number of oxygen atoms of an element. So you can remember any one of these definitions. So generally speaking, you remember whenever an element, whenever a substance, it will gain oxygen, it will undergo oxidation. For example, simple chemical equations, I am showing you these chemical equations are the reactions of oxidation. They are following the definition of addition of oxygen. For example, if we mix any metal with oxygen, what will happen? Oxygen is added into magnesium. Oxygen is added into metal. When metal will get oxygen, will gain oxygen, when the number of atom of oxygen will increase with magnesium, you can see on the left hand side when we started the reaction, on the left hand side when we started the reaction, here magnesium, it was not having any oxygen, but after the reaction magnesium, it has gained oxygen. So we can say this is a reaction for the oxidation, and this is oxidation due to gain of oxygen. Another example, if likewise instead of metal we take some non-metal like sulfur, if it is mixed with oxygen, we will again get sulfur oxide. So whenever oxide of an element is produced, it means that element is undergoing oxidation. So this is simple thing to be remembered. Whenever oxide of any element, whether that element is metal or non-metal, whenever oxide of any element is produced, it is the process of oxidation. And which definition we are following? We are following the process of addition of oxygen. Likewise, as I told you earlier, for reduction you must remember which element in your mind? Hydrogen. Oxidation is the addition of oxygen. Reduction is the addition of hydrogen. Whenever hydrogen is added into a substance, it is reduction. A very simple example from your previous class, you can recall, you can remember, it is the addition of hydrogen to an alkene. Whenever we add hydrogen into an alkene, this addition of hydrogen, it is reduction. What you can see, hydrogen has been added, hydrogen has been gained. You can also see the number of hydrogen atom has increased in this compound. In alkene, how many hydrogen atoms were present earlier? 4. But after the reaction, there are 6 hydrogen. So what you must remember, you can say reduction is the addition of hydrogen, reduction is the gain of hydrogen, reduction is the increase in number of hydrogen atom into a substance. So you can remember any one of these three definitions. Okay, now this is very simple, students. I have given you very simple idea how to start with the definition of oxidation and reduction according to the classical method. Second thing, now we are going to modify this, but to start with, just remember oxidation is the addition of oxygen, reduction is the addition of hydrogen. Now we are going to reverse these two definitions. The definition that we have already written, if we reverse them, we will get another definition for oxidation and reduction. How to reverse? See, one definition for oxidation is written in front of you. It is addition of oxygen. At the same time, you can remember oxidation is the removal of hydrogen, because we have added oxygen. We cannot add hydrogen and say this is oxidation. No, we added oxygen. Addition of oxygen is oxidation. So removal of hydrogen would be another definition for oxidation. So you must remember the second definition, and now I am confident that you would have become able to define reduction. The second definition of reduction you can write on yourself. Yes, what will be the second definition of reduction now? It is the first definition. It is the addition of hydrogen. If it is the addition of hydrogen, what it should do with oxygen? Yes, there must be removal of oxygen. So to start with classical definition, always remember oxidation is related to oxygen, reduction is related to hydrogen, addition of oxygen, oxidation, addition of hydrogen, reduction. And if you just reverse these, that you say removal of hydrogen, even then it is oxidation, and removal of oxygen, it is also reduction. Okay, now based on these definitions, how a question can be asked in your final exams, in your entry test exams. um, Look at the question. The question, whenever it is given, the first thing that you must look at, that which definition you have to apply on the given chemical reaction. Look at, this is a chemical reaction where iron oxide, it is reacting with aluminum metal. What you can see, which element, oxygen or hydrogen, you can see in this equation, you can see oxygen. So it means we are going to apply the definition in terms of oxygen. What you can see, you can see before the reaction oxygen was present with iron, and after the reaction oxygen has been taken by the aluminum. What does this mean? It means aluminum, it has gained oxygen. Gain of oxygen is oxidation. So aluminum has been oxidized, but which element has removed oxygen? Which element has lost oxygen? Iron. So what does this mean? It is very simple. If aluminum has gained oxygen, aluminum has been oxidized, and then obviously iron would have been reduced. So in this case we have applied the definition in terms of oxygen. It is not necessary always that you are given a reaction where there is the exchange of oxygen. Not necessarily. You can be given a reaction where you may find that there can be the exchange of hydrogen. If in a given chemical equation, if in a given chemical reaction you see the exchange of hydrogen, then you will have to use the classical definition based on hydrogen. In this case, look at, we are having hydrogen with sulfur before the reaction. After the reaction hydrogen has been taken by fluorine, so exchange of hydrogen has taken place. Which element has gained hydrogen during the reaction? Sulfur was having two hydrogen. After the reaction sulfur is having no hydrogen. So sulfur has lost hydrogen. Loss of hydrogen, removal of hydrogen, what it is known as? Look at the definition. It is known as oxidation. So it means sulfur has been oxidized. Sulfur has been oxidized. Again you can see why sulfur has been oxidized, since it has lost hydrogen, since it has removed hydrogen. Removal of hydrogen is oxidation. Likewise you can see which element has been reduced. Fluorine, because before the reaction fluorine was having no hydrogen, but now fluorine is having hydrogen atom. So gain of hydrogen, addition of hydrogen, it is reduction. So in the first example that I have told you, we have applied the definition based on oxygen because exchange of oxygen was taken place, but in the second reaction we used the definition based on hydrogen because exchange of hydrogen atom has taken place. Now in your exams it is also possible that you may be given a chemical reaction where both hydrogen and oxygen may be present in the same chemical equation. Then what to do? Look at this example. This is a chemical reaction for the combustion of methane gas. Now what you can see during this combustion, carbon dioxide and water has been produced. What you can see, in this case hydrogen is present, in this case oxygen is also present. Whenever both elements are present in a chemical reaction, what you must look for? You must look for which element is involved in the process of exchange. The element that is involved in the process of exchange, you must write down answer based on that definition. Now in this case there is oxygen, there is hydrogen, no doubt, but which element is being exchanged? Look at, before the reaction carbon is having hydrogen. After the reaction hydrogen is present with oxygen, not with carbon. So what does this mean? Which element has been exchanged? Hydrogen. Carbon had 4 hydrogen. After the reaction carbon has no hydrogen. So it means carbon has lost hydrogen. Carbon has removed hydrogen. So what you can say? You can say during this reaction carbon has been oxidized. During this reaction carbon has been oxidized. Why? Because loss of hydrogen is there. And which element has gained hydrogen? Oxygen. Oxygen was having no hydrogen before the reaction, but after the reaction oxygen has 2 hydrogen atoms. So it means hydrogen has been removed from carbon and it has been added into oxygen. carbon has removed hydrogen, so carbon has been oxidized and oxygen has been reduced. So whenever you are given this type of reaction where both the elements, both hydrogen and oxygen are present, the important thing, the shortcut method for your entry test, it is that you must look at which element is being exchanged. That will be the definition which you will have to apply. So student, this is the concept for the classical definitions of oxidation and reduction. Now what is the problem? Sometimes we come across such type of chemical reactions where there is no oxygen, where there is no hydrogen. So obviously if we are given a chemical reaction like this, look at this chemical reaction. In this chemical reaction, is there any oxygen? No. Is there any hydrogen? No. So what does this mean? It means we cannot apply any one of the two definitions, classical definitions that we have already studied. Likewise, look at this example. In this example, we have hydrogen, we have oxygen, but this is a complex chemical reaction. Whenever you are given a chemical reaction where there is no hydrogen, no oxygen, or you may be given a chemical reaction that is complex, it may have hydrogen and oxygen, but it is complex. In such type of chemical reactions, we are unable to apply classical definition. Whenever we are unable to apply classical definition, we have to use modern definition of oxidation and reduction. So there are some limitations of classical method. That is why we have to focus on modern concept of oxidation and reduction. So let's discuss now what is the modern concept for oxidation and reduction. Students, remember, in the modern concept, again there are two different definitions that we use for oxidation and reduction. One definition that we use commonly for oxidation and reduction, it is in terms of electron transfer. And the second definition that is very important in the modern concept, it is in terms of oxidation state or in terms of oxidation number. Oxidation state, it is also known as oxidation number. Right now we are going to we are going to focus on electron transfer definition according to modern concept. How we can define oxidation and how we can define reduction. Very simple. Look at this. According to the first definition of modern concept in terms of electron, what you must remember, in terms of electron, oxidation, it is the loss of electron. Oxidation is the loss of electron. Remember, whenever there is oxidation, there would be loss of electron, removal of electron. And what is reduction? Just remember what is oxidation. You can yourself recall what would be reduction. If oxidation is the loss of electron, what would be the reduction? Reduction would be the gain of electron. So just in this definition, you will have to remember only for oxidation. What is oxidation? It is loss of electron. If it is loss of electron, the reduction would be obviously gain of electron. I can also tell you another shortcut method so that you are never ever you will be confused to give an exact definition for oxidation and reduction. What you can remember? You can remember oil rig. Oil rig. Oil oxidation is loss. Oil rig oxidation is loss. Rig reduction is gain. So this is very important shortcut that you can remember. You will never ever forget what is the modern definition in terms of electron transfer. In terms of electron transfer, the modern definition of oxidation and reduction is oil rig. Oil is the oxidation is loss. Rig reduction, it is the gain. So always remember, according to this concept, oxidation is the loss of electron, reduction is the gain of electron. Now how different type of questions can be set in your exams related to this definition in terms of electron. One type of question that can be asked in your exams, you may be given a compound, an ionic compound. Ionic compound, you people know, mostly they are made up of metal and non-metal. How you will come to know which element is metal and which one is non-metal? There are three different methods by which you can identify. First of all, look at the chemical formula that is given to you. Always remember the element that is written first in the chemical formula of an ionic compound. The first element, it is always metal, and metals lose electron easily. Metals lose electron easily. The second element that is always written in the chemical formula of an ionic compound, it is always non-metal. And remember, non-metals gain electron easily. Metal lose electron, non-metal gain electron easily. This you must remember. So next thing, periodic table is available. You can look at the periodic table. From the periodic table, you must look at each element given in the chemical formula, it belongs to which group number. Why group number is important? Because group number tells us about the number of valence electrons. If you look at the periodic table, you can see aluminum. It belongs to group number 3. It has 3 valence electrons. How you must distribute electrons around an atom? The valence electron, since they are 3, you must distribute like this. Now, why this distribution is important? Because this distribution clearly tells us about the definition of valency. This distribution clearly tells us about the number of bonds aluminum can make. So, valency, how you can define valency? You can say valency is the number of unpaired valence electrons. Valency is the number of unpaired valence electron. So what you can see? You can see aluminum has 3 unpaired valence electron. So aluminum, it could make 3 bonds. It could lose 3 electron because it is a metal and metal lose electron easily. So aluminum will lose 3 electron. We have come to know by distribution of electron. Next, you will see oxygen in the periodic table. Oxygen belongs to group number 16. But if we exclude the 10 groups of the transition metals, we can say oxygen belongs to group number 6, since oxygen has 6 valence electrons. Now, when oxygen has 6 valence electron, and if you don't remember the valency of oxygen, no problem. You can find the valency yourself. How is that? You will write down oxygen, distribute the valence electrons of oxygen like this. First of all, you must place 1 electron on each of 4 sides. Now what you can see, how many unpaired electrons are there? 4, but still we are having 2 more electrons of oxygen. So what we will do, we will place 2 more electron. After placing 2 more electron, now what you can see, in the valence shell of oxygen there are how many unpaired electrons? So you can get to know that one oxygen, it can make 2 bonds. One oxygen, it has a valency of 2. Valency is the number of unpaired valence electron. So oxygen can gain 2 electrons. Okay, now students, you have come to know that which element is going to lose electron easily, aluminum, and which element is going to gain electron easily, it is oxygen. So what you will do now, loss of electron is oxidation. Which element will be oxidized? Aluminum will be oxidized. Aluminum is going to lose through 3 electrons. Remember, before the loss of electron, number of electrons, they are equal to number of protons. That is why aluminum, it has no charge, it has 0 charge. Why? Because number of protons are equal to number of electrons. Now when aluminum, it would lose 3 electrons, when it would lose 3 electron, the electron number will become lesser. When electrons will become less, which subatomic particle will increase in number? Proton. and you know what is the charge carried by proton? Positive. And aluminum has got how many more proton now after the loss of 3 electron? Aluminum has 3 more proton. So that is why always remember, whenever there is loss of electron always produces positive ions or cations. Why? Because protons, they become greater in number than electrons. Now students, it would have become quite easy for you people to write down equation for oxygen. You have come to know one oxygen will gain 2 electron. So when oxygen will gain 2 electron, number of electron of oxygen would increase by 2 units. When there are 2 more electron, that is why during reduction we get which ions? Negative ions are produced, or negative ions can also be known as anions. So remember, during loss of electron, positive ions; during gain of electron, negative ions. But what is the problem with oxygen? Oxygen is a diatomic gas. It is O2. Right now we know one oxygen gains 2 electron, but we are having 2 atoms. So for 2 atom, how many electron we will have to provide? 4 electron. Yes, when you will provide 4 electron, each oxygen will get 2 electron, we will get a charge of 2 negative, but to balance it we will multiply 2 before oxide ion. Now your equation is balanced. Aluminum is having 3 electron and oxygen is having 4 electron. Each equation is balanced, but first equation is oxidation, second is reduction. And what I have told you, without oxidation, reduction is not possible. Without reduction, oxidation is not possible. So first equation is known as oxidation half equation. Second equation is known as reduction half equation. If you take the sum of oxidation and reduction half equation, what it can become? It can become redox reaction. Redox reaction. Now whenever you want to take the sum, before sum, what you must do? You must cross multiply the number of mole of electrons, so that electrons must become equal and they must be cancelled out. What does this mean? What I am saying? I mean, look at the first equation. In the first equation we are having how many electron? 3. And in the second equation we are having how many electron? 4. So what we will do? We will multiply the first equation by 4. Why? Because number of mole of electron in the second equation is 4. And we will multiply the second equation by 3. Now what has happened? 4 3s are 12, 3 4s are 12. Electrons are equal, they will be cancelled. Now when you have cancelled the electron and you will take the sum of oxidation and reduction half equation, it will become redox equation. Now let's make the redox equation. You can write down Al plus O2 gives Al3 positive plus O2 minus, but you must also multiply the coefficient. Aluminum will be multiplied by 4, aluminum ion by 4, O2 by 3, oxide by 6, because already oxide ion is having a coefficient of 2, this one. You can see this is 2, this 2 will be multiplied by 3, 3 2s are 6, here you will write down 6. So see the coefficients that must be introduced: 4 3 4 6. This is the redox equation. This is one type of question that can be asked in your exam, that a compound is given, you have to write down oxidation, reduction and redox equation. In the next type of question, sometime you may be given a redox equation. What you will have to do? You will have to write down oxidation and reduction equation, and then again you can take a sum to get this final equation back. Now what you will do again, whether you have been given this formula of an ionic compound or this chemical equation, it doesn't make any difference. Look at this compound. The first element, it would be metal. Second element, non-metal. Metal lose electron easily, non-metal gain electron easily. What you will do? Again with the help of periodic table, Find the group number of sodium. It belongs to group 1. So it means it will lose one electron. So what will be the charge after losing? I told you electrons are lost. It means number of electron has become lesser. Protons are more, positive charge. So sodium would make positive ion cation with a charge of 1 positive. Sulfur. Sulfur again belongs to the group number 6, the group number of oxygen. Sulfur has 6 valence electron. After distribution, what you can see, how many unpaired sulfur is having? 2. So sulfur can gain 2 electrons. Now you can pause the video, you can write down the equation, then I can show you the equation. Okay students, if you have written, just look at sodium, it would have lost 1 electron. After losing 1 electron, sodium must get 1 positive charge. But sulfur, it gains 2 electron. After gaining 2 electron, sulfur would get a charge of 2 negative. Now if you want to make the redox equation, before taking sum, what I told you, you must balance and cross out the number of electrons. How to balance electron in this case? The first equation, if it is multiplied by 2, your equation will be balanced. No need to multiply the second equation, since the number of mole of electron in the first equation, in the oxidation, it is 1. So electrons are balanced, crossed out. What final redox equation you will get? 2Na positive, S gives 2Na plus sulfur gives 2Na1 positive plus S2 minus. This is the final redox equation. It doesn't make any difference whether you write down final product as positive and negative ion, or you just write down the formula. It's all right. It is absolutely all right. You can write down the final answer either in compound form or into the ionic form. It is all right. So these are the two styles of question that can be asked in terms of electron. Now one more advantage of electron transfer definition that you must remember. You must remember, in terms of electron definition, in terms of electron transfer definition, what is the advantage? We can decide about the reactivity of metals. If you have been given two metals, you can come to know which metal is more reactive and which one is less reactive. Look at, for example, if you are given zinc metal, zinc rod, and you dip in zinc metal into copper sulfate solution, zinc metal into copper sulfate solution, copper sulfate solution is blue, zinc is a metal, silver gray metal. When you will dip in silver gray zinc metal into blue solution, what will happen? What will happen? Zinc will undergo oxidation. What is oxidation? Loss of electron. So zinc will undergo oxidation. So copper will have to undergo reduction. But if you want to carry out the reverse reaction, if you take zinc solution and dip in reddish brown copper metal, what will happen? In the first case, I have told you zinc will be oxidized, copper will be reduced. But in the second case, no reaction is possible. When there is no reaction, what does this mean? It is obvious that which metal is able to lose electron more easily, that would be more reactive. So whenever you have been given two or more metals, the metal that can lose electron more easily, it is a reactive metal. So in terms of electron transfer definition, we also become able to decide about the reactivity of metals. Students, I hope you would have enjoyed this lecture. If you have any questions regarding this lecture, you can write down your question in the comments below. I will give answer to your questions as soon as possible. Thank you for your time. Bye.